All right, let's go over some acceleration problems. And what I mean by acceleration is that problems that have an object that's undergoing some type of change in velocity. Now, in these types of problems, they might use the word speed. Okay. In general, there is a distinct difference between speed and velocity. Speed is a change in distance, while velocity is a change in your displacement. Okay. For a lot of these problems, the distance and the displacement are the same values. So we use the word speed interchangeably with the word velocity in a lot of these kind of problems. So don't let that kind of a thing confuse you. You only need to really be concerned if an object turns around or anything like that. Then you're going to need to analyze it slightly differently. Our acceleration equation, let's start off with that. It's acceleration is equal to delta v divided by delta t. Now, we can expand that to being our final velocity minus our initial velocity divided by delta t. Okay. Now, delta t, this part right here, technically that's t final minus t initial. We do the best that we can to try and get t initial to 0, meaning we always try and analyze the problem from a viewpoint of the clock starts at the beginning of the problem, and that tends to work pretty well for most scenarios. We can expand this. Okay, a common rearrangement of this equation is v final is equal to v initial plus a times delta t. Okay, and that's a pretty common equation that we like to use. The biggest issue with these equations are usually the units that the numbers come in. You want to kind of think of it as a recipe. Okay, when you're cooking bread, if someone was to give you just straight wheat from the field and tell you to make bread, you need to adapt that and make it into flour. And we're all like, well, duh, that makes sense. Okay, but when we get numbers, people just sometimes just start plugging numbers into these equations without considering what format the numbers are coming in. So that's a big issue that we have. Okay, let's do a couple of problems here. I suggest when doing these types of problems that you approach it from the viewpoint of making a list of givens first. Okay, that's going to help us quite a bit. By making a list of givens, we can go a long way. So let's do this problem. We've got a cart rolling down an incline for 5 seconds. So I already know right off the bat I've got a t equal 5 seconds. You'll notice here I didn't even put a t initial or t final. The t initial would be 0. The t final would be 5. So that represents my delta t. Okay, and has an acceleration of 4 meters per second squared. If the cart has a beginning velocity of 2 meters per second, what is the final speed? So my initial velocity there, that's that 2 meters per second. Okay. Now, when we look at this, you'll notice it's asked, what's the final speed? Remember how we said we could use the word speed and velocity interchangeably? Well, here we're just going to write that as our final velocity. That's our question mark. Now, right off the bat, we know we've got an equation right here. That works really well for that. So we're just going to go v final is equal to v initial plus a times t. Okay, for that equation, we're just going to start plugging values in. Okay, we got v initial right here, acceleration right here, and then our time goes in that backside. So v final is equal to 2 meters per second plus 4 meters per second squared times by 5 seconds. Okay, doing the math, 4 times 5 is 20 plus 2 is 22. Now we need to make sure our units match up. I've got meters per second plus, then I got this, jazz here. This second cancels with that squared, leaving me with meters per second plus meters per second. That just gives me meters per second. Okay, and that's a pretty simple problem. Let's look at another problem here. Okay. This is a little bit more complex. Okay, let's look at this. We got a car can go from 0 to 60 miles an hour. We can go from 0 to 60 mph in 8 seconds. Okay. Assuming that it can continue that acceleration. So right there, just by listening to the problem statement, we can say, okay, this is acceleration information. Acceleration info right there. What would be the car's final velocity? So it's already saying, okay, v final, that's what we're looking for, after 5 seconds. So my delta t, or my t value, that's going to be 5 seconds. If it starts with a velocity of 50 miles an hour. So my initial velocity is 50 mph. Now when we look at these kind of problems, we can't use miles per hour. At least, it's not that you can't use them, it's just we have an issue of units here. I have hours here, and I have seconds here. So I have a difference of time units, and that's not good. In general, for my class, I'm going to require that you give all your answers in either meters per second or feet per second. Okay? So the equation that we use, we're going to go right back. We're going to say, I'm going to use this equation again. Okay, that's pretty straightforward. But I don't have really any of those values except for 5 seconds in the right form that I want them to be in. Okay, so first thing I need to do, I need to take this 50 miles per hour and I need to convert it into feet per second. Okay, and how we do that, we just do a simple conversion. Okay, let's do this right here. So 50 miles an hour. If I want to get rid of miles, I need to put miles on the bottom, since miles is on the top. I need them one on top, one on bottom for them to cancel out. So put miles down here. And then I want it to be in feet, so I'm going to drop feet up there, see if I can find a conversion for feet. So in 1 mile, I have 5,280 feet. Okay, remember that from Remember the Titans, how many feet are in a mile? Okay, so there you got that. Now I need to get rid of, so my miles cancel, I need to get rid of hours now. So since hours is on the bottom here, I want to put on the top over here. So you got hours there, okay, and I want it in seconds. So in 1 hour, you have 3,600 seconds. Hours cancel. So plug that in, do 50 times 5,280 divided by 3,600. You should get a value of 73.33 repeating in feet per second. I've got feet on top, seconds on bottom. That's how I know I did it right. My end units confirm that. Okay, so that value, that right there, goes in for my initial velocity. Now I have an issue. I don't know what my acceleration is. Now remember, my acceleration, that is this equation, that v final minus v initial divided by delta t. Now I know what the delta t is for that. That's at 8 seconds, right? But I don't know what v final is because I have 60 miles an hour, and once again, I don't have 60 miles an hour in feet per second. I need it in the right units. Okay, now my initial velocity, that's easy. That's just 0. So using the same conversion I do right here, except I use 60 instead of the 50 that's right there, I get a value of 88 feet per second for my v final on that equation. Plug that in, and you get a value of 11 feet per second squared. Okay, that goes in for that. So by final equation, if I'm going to write this out, I've got v final is equal to 73.33 feet per second plus 11 feet per second squared times by 5 seconds. The seconds there cancel there and there. Put in the calculator. You're going to get a value of around 128.33 feet per second. That's in the right units. That's the units for velocity. We have a displacement over time. And that should be about as it gets. Any other equation really shouldn't take you through much more than that, at least on your homeworks. Okay, so as you look at that, that's really the process that we go through. If you have any questions on that, let me know. Love to answer whatever questions you might have.